guys, so this is our polynomial sig test. So first I'm writing out the problem, and what you want to do is you want to isolate that y variable on that one side so you can properly see the slope, and it's going to be much easier to plug in things later. So we know that it intersects at x equals -2, so basically what we're doing right now is plugging that point in to find out what the y coordinate is, so you have a full point and you can plug that in later and make sure everything's okay. So basically isolating everything again, and you get y equals 5. So basically it intersects at -2 and 5. Our next main thing we have to do is find the slope. Now because this is perpendicular to the equation given, we know that its slope is the negative reciprocal of that. So basically, again, it's right now it's -1/2, the negative reciprocal of that, 1/2, reciprocal 2. So basically the slope is 2. So now that you have all your points, you can plug this into point slope form as the question entails. So that's going to end up being y minus 5 equals 2 times x plus 2. Make sure be careful about that. And then again, isolate your y variable, and this is our f of x function that we will be using in part C.
Alright, so this next section is a little more complicated because it's a fourth degree polynomial. So we know we have our three zeros, x equals 0, x equals 4, and x equals 6. So you can start writing those out in your format, which is like x minus 4, x minus 6, and this is a g of x function, comes up in the next part. So we see that this is also a fourth degree function, so we know that there needs to be something else squared. Now because the local min is at 0, we can square that because we know it just touches the x-axis. So now we need to know our c, which is an integer that goes in front that basically kind of finishes off the polynomial. So we know this by putting, well, obviously you put this at the front of g of x, and we can solve for this by using our local maximum, which is an actual point. So basically c, which is 2 squared minus x, or 2 minus 4, 2 minus 6, equals 16. So now you're just going to do general algebra and solve this out. So c times 4 times -2 times -4 equals 16. C times 32 equals 16. So c equals 1/2. So now you just put the entire thing together for the g of x function, which is going to equal 1/2 x squared, x minus 4, and x minus 6. And there you go. Now our final portion of this is our basically where it goes from -infinity to +infinity. First one's easy, it's a positive slope, it's a linear graph, so we know that it's going to be going -infinity, -infinity, +infinity, +infinity. The polynomial is a little bit more tricky, and I highly recommend actually graphing it and using the information given. This is where you're going to use a lot of your like minimums and maximums and stuff. So just really fast, I'm plotting out where those zeros will be. Next, I know that there's a local maximum at 2 and 16. And also we know there's two local minimums, one at 0, which is right there, and one also at x equals 5, which is going to be presumably below there because we know that it only touches the graph at 0, but then goes through at 4 and through at 6. So now we have our graph and we know that it goes to positive infinity in both places. So good job, guys. Good luck on the SIG test. Bye.